Whoa, what happened? Okay. Hey, so I made a YouTube account. So from now on, whenever I make a video for you guys, you won't get a video on your wall anymore. You will get a YouTube link. So, yeah. Also, if you have a YouTube account, subscribe, like my videos, please, because it will help me and I help you. So it works out. So anyway, let's do some math. Okay, so the problem has a diagram, so I will draw the diagram. First of all, 2 to the x looks pretty much like e to the x because if you think about it, e is 2.7 and 2 is really close to that. So your graph looks like this. Alright? Now, should I have drawn it bigger? Yes, let me draw it bigger. Okay, so now we have 2 points. Okay, this is 1 and this is 2. So that means this is 1 and whatever. So you are given the tangent line, right? And they actually give you the tangent line, and which is pretty stupid because you could calculate it yourself. Anyway, I'm just going to go with it because I don't have that much time anymore. So tangent line would be 2, 3, 3, or 3.386. This is 2, 0, 1, 0, 1, 1. Right? Right. That's 2, 1, 2. Alright? So, let me draw the function y equals 2 to the x. Alright, so now, what they want you to do is, just going up here, they want you to find the max and the min, but this is not supposed to be just rectangles, because if you have one rectangle, it's going to look like, this is going to be really rough. So here's what they want you to do. They want you to use this diagonal, because the diagonal is a better estimate, right? Remember how we were estimating the value? So the diagonal, where's my blue hash marker? Here. It's a better estimate. So now if you take this area, it is the lower estimate. Now, how do you find the higher estimate? You take, again, this point right here, and now you move this point up to here, where it intersects up here, right? And you draw this, and then this area right here is your higher, and you add that onto here. And this point up here is 2, well, I don't know. Let's see. 2, oh, it's 4. Okay? So, let's actually do this. Alright, so I'm just going to do the method rectangle and triangle. So the rectangle is 1, because this is the length, right, times the width. This is 2 units high, so it's 1 times 2, which is equal to 2, and that is equal to the rectangle. Alright, so now I'm going to find the triangle. Again, the length is 1, but it's 1/2, remember the triangle, times 1 times the height. The height goes from 2 up to 3.386. So that has a difference of 1.386, and that is equal to, I actually don't know. I didn't calculate it because I did triangle and rectangle together. So now, rectangle plus triangle equals to 2.693. And that is your lower. Am I in the way? I'm good. Alright? Now, higher, remember, again, you calculate the rectangle, and we already have the rectangle, except I was stupid, I didn't calculate it. But it's just 2. Yeah, it's 2, and then you add the triangle to it. So, the triangle now, since this point is 2, 2, up to 2, 4, the height is 2, right? Because it goes up to 4. So now your area is 2, because it's the rectangle, plus the triangle. So 1/2 length times width. Length is 1, plus width, which we just said is 2, or height, I guess. So that is going to be 3, right? And that is your higher. Alright, so lower goes up to the tangent line like this, and the higher goes up to the point up there. So it intersects twice. Alright? That is 1A. What are we doing with time? 5 minutes. Alright, that's okay. Let's leave the diagram because it's gonna come up again. Whatever. Alright, now for B, it wants you to do 5 intervals. Maybe I should draw this again. Here. I don't need the tangent line anymore, I don't think. No. Okay. So now, here we go. Alright, so this wants to, this should be 5. So 1, 2, 3, 4, 5. This goes up here, up here, up here, up here. Alright, so I'm doing the rectangle method, whatever the guy's name is. Alright, so now first your minimums. Your minimums is from the left side over onto here. Alright, like this. So you calculate the area of each rectangle. So from 1 to 2, the distance is 2. So each one of these little lengths is going to be 0.2, right? Makes sense because it's 1/5 of 1. Okay, now let's do your lengths. Your lengths, if you notice, they all intersect with your function. So if you take your x value at this point and plug it into your function, you will get this point and therefore your height. Okay? So let's do this. For your first point, you plug in 1 because you start at 1. So 2 to the 1 is 2. So then, actually, you can factor out the point 2 so that you can just add all of these together. So the second point is 1.2, so you get 2 to the 1.2 plus 2 to the 1.4. This is your third point, right? We're just adding 0.2 plus 2 to the 1.6 plus 2 to the 1.8. Now, we are not doing 2 because, check it out, 1.8, this is this point right here. It goes up here, and that is your last rectangle. Remember, you have 5 rectangles, right? So now, you do this, and if you actually do this, you will get 2.6898. And that is your lower limit because you add all these guys up, right? Now, let's get to your higher. Alright, that's what it should look like. Now, notice, now the right side of the rectangle intersects with the function, so now you take the right side. Now, the cool thing about this is, you can use the very same thing, but you gotta take the 2 away, because 2 to the 1 is no longer the point that you look for, it's this guy. So you jump one over, jump one over, jump one over, until you add finally 2 to the 2, which we already know is 4. So we add 4 right here. Because, I hope this makes sense, because the lower limit, or the lower area, it takes the left side of your little bar into consideration, while the higher takes the right side. So we pick the left side and we ignore the far most right side, which is 2, and for the higher we take all the right sides and ignore the most left side. Alright, so if you do this, you will get, this is your lower, and your higher would be 3.0898. Okay? Cool. Now for C, honestly, I checked the back of the book and just copied it. All it does, because I don't want to put in the CD. I'm going to be honest with you. I don't care about the CD. But honestly, all the book is doing is, you have, what the CD is doing is it's saying, okay, so you have 5 bars here, right? So what if you have 10? Right? When you have 10 and you do the area, those little triangles that form up there in between are little. They're getting smaller, right? So therefore, the amount that you're off, your actual area, is getting smaller. So now what if you have 20? I'm not going to really draw lines, but imagine you have 20. So the area even gets smaller, so therefore you get closer. Take 1,000 rectangles and you get closer. Now, what if you have infinite many rectangles? You get the actual area. That's all it is. And that's what integrals are about. You take infinite many rectangles. And you will learn next class how to do that. I'm not going to teach you right now. How are we doing with time? 11 minutes. Okay. So, I'm going to teach you one thing real quick before I make a new video because we're going to run out of time. So, if you take your calculator, I'm going to show you this because Miss Wonder didn't, and this might come in useful. You go to y equals, this is actually not it, and you type in your function 2, actually I'm going to do this right now, 2 to the x, right? Graph. Alright, that's 2 to the x. I didn't lie to you, it looks like that, okay? So now you do second, right here, calculate, here, and you go f, or integral f of x dx. That is the integral. Lower limit is 0, because, you know, we're going, oh, it's not 0, it's 1. My bad. It goes from 1 to 2, so lower limit 1, enter, upper limit 2, enter, and bam, that's your area. Is that easy? Don't tell Miss Wonder I showed you this, she'll get angry. So yeah, that is 1A.